Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video we learned question number 7, which is the last question of exercise number 3.2 related with the topic angle of intersection between curve. In today's video I am going to start a new exercise number 3.2 related 3.3, which is the last exercise of chapter number 3, higher order derivative and application FSC part 2 mathematics. So let's move toward question number 2 of exercise number 3.3. It tells that find the critical values of functions and show where the function is increasing and where the function will be decreasing. Plot each critical point and label it as the function is either relative maxima or relative minima or neither. So it means there are three parts in this question. First we will find critical values, then we will show increasing, decreasing function, and the last we will find the relative maxima and relative minima. So move toward the solution of this problem. First, let's suppose f of x is equal to y, which is equal to x cubed plus 3x squared and plus of 1. So differentiating both sides with respect to x, so our dy by dx will be derivative of x cubed is 3x squared and derivative of 3x squared is 6x, and derivative of 1 is 0. Remember, for the critical point we make the first time derivative equal to 0, so dy by dx will be equal to 0, 3x squared plus 6x. Now on the right hand side, take out 3x common, inside we are left with x, and from over here if I take out 3x common, I will left with 2 is equal to 0. Now using zero factor property, so 3x will be equal to 0 and x plus 2 will be equal to 0. So from over here x will be equal to 0 and here the solution will be x is equal to minus 2. So these are the two critical points. So the critical points of the original function is of 0 and minus 2. Now after this I am going to find the increasing and decreasing function by plotting a number line. Let's suppose this is negative infinity and let's suppose this is positive infinity. Toward negative infinity I will take the negative solution, which is minus 2, and toward positive infinity I will take the positive solution, which is 0. Now let's suppose I take the number in between 0 and minus 2, in between this interval minus 1. So by putting minus 1 in this y is equal to x cubed over here dy by dx, if I put x minus 1, so it becomes 3 into minus 1 whole square plus 6 into minus 1, so it becomes 3 minus 6, which gives us minus 3. As minus 3 is less than 0, it means that the function is decreasing in this interval, decreasing. Now I take minus 3 inside this interval, minus 2 to minus infinity. Let's suppose I take minus 3 in this interval. So by putting minus 3 over here, it will give us minus 3 over here becomes minus 3 square, so it will give us 9. 9 multiplied 3 will give us minus 27. 3 into x is, let's suppose, minus 3. So minus 3 whole square plus 6 into minus 3. So minus 3 whole square 9. 9 multiplied 3 gives us 27. And it will give us minus 18. So the result is 9. So 9 is greater than 0. It means the function is increasing in this interval. Now if I take 1 in this interval, so it becomes 3 into 1 square gives us 3. And if I put 1 over here, it gives us 6. So the result is 9, which is greater than 0. It means the function is also increasing in this interval. So we can write just like decreasing. The decreasing interval is 0 to minus 2, and increasing interval is from minus infinity to minus 2, union 0 to infinity. These are the increasing interval. Now after this I am going to find the relative maxima and relative minima. For the relative maxima and relative minima, I will differentiate the first time derivatives. For the second time derivative, so it becomes d square y by dx square will be 3x square derivative is 6x, and derivative of 6x is plus 6. Now I have two solutions. At x is equal to 0, it becomes it will give us a value of d square y by dx square. If I put 0, it gives us 6. As it is greater than 0, so when the second time derivative is greater than 0, and then there will be a relative minima. Now taking again d square y by dx square, which is equal to 6x plus 6. So putting x is equal to minus 2, it becomes minus 2 into 6 gives us minus 12 plus 6. As the result is minus 6, which is less than 0. So when the result is less than 0, then there will be a relative maxima. Now I am finding the value of relative maxima and relative minima by putting this solution in the given function. So by putting x is equal to 0 over here, it will give us 0 plus 0, y will be f of x or y will be equal to 1. So at x is equal to 0, the value of y is 1. So at 0 the function is relative minima. So at 0, 1 we have our relative minima. And if I put x is equal to minus 2 in this function, it gives us minus 2 whole cube plus 3 into minus 2 whole square plus 1. So minus 2 cube gives us minus 8 plus 1. Minus 2 square gives us 4. 4 multiplied 3 gives us a value 12. 12 plus 1, 13. 13 minus 8 gives us a value of y is pi. So at x is equal to minus 2 we get the value of y is pi. And at x is equal to minus 2 we have the function relative maxima. So at this interval, at this value, we have a relative maxima. Now that is a plot each critical point and label it as a relative maxima or relative minima or neither. So let's suppose this is the graph. This is, let's suppose 4. Let's suppose this is 8. Let's suppose this is minus 4. Let's suppose this is minus 8. This is minus 4. This is minus 8. Let's suppose this is 4 and let's suppose this is 8. This is 8. Now at x is equal to 0 we have a value of y is pi. Let's suppose this is x and let's suppose this is x which is 0, and let's suppose this is the value of y which is 1. So let's suppose this is 0 and 1. And also we have at x is equal to minus 2. Let's suppose this is minus 2 and the value of y is pi, which is, let's suppose this over here. So this is the point. So at x is equal to minus 2 we have the value of y is equal to 5. And after this we have no interval. So this will pass just like this just like this. So this is actually the graph which is occurring and passing to the minus 4, minus 3, minus 2, and over here passing to the 2. So this is actually the graph. These are the critical values. The critical values are 0 and minus 2. Over here we have 0, and over here we have minus 2. So this is actually passed from the minus 2. So this is actually the graph for the question number 2. So with this question I finish my lecture. Thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification about second year mathematics. Thank you.